Welcome and welcome. We're going to go through today DOGOps. My name is Brandon Young. I'm with GitLab, and I lead up all of our alliances. So kind of give you context on that. That means I work with Amazon. I work with all of our partners. Probably work with a bunch of you. Today, what we want to do is give you a little bit of context of what you're seeing first. So I'm going to give you a little context of what Wag is using. And then we're going to spend the majority of the time, because I think you all are here not to hear from us, but to hear from Dave and the team at Wag on what they're up to. We're going to cover today a pretty wide variety of pieces. So with that said, I want to introduce Dave. Dave is the VP of Engineering at Wag Labs. We are going to do our very best today to do as many dog puns as possible. I'm not nearly as good at it yet, but I've been practicing.
It's going to be possum.
It's going to be possum? Possum. Excellent. We're in. So a couple of context in terms of what we see. So first off, GitLab, from the simplest of terms, is a single DevOps tool that does everything from your planning to your deployment and your securing in between. We'll spend a little bit of time so you know and you'll understand what Dave's actually using. We think pretty simple in the world. We think the thing that matters the most is radically faster DevOps lifecycle. And that means that dev has to work with ops, means it gets to production, idea to production in the fastest possible process. Most of us have obviously heard that software's eating the world. That's long since gone. I think this is the quote, and it's also the part we believe in our heart when we at GitLab, what we think matters the most to our customers, and that is cycle time. Now, cycle time, you can say from idea to production, you can call it many things, but the functional reason this matters a lot is the world's moving very quickly. You've got to be able to take something from an idea and get it out to a customer as fast as possible. That customer may be internal, the customer may be on an iOS app, they could be anywhere. This also applies to a couple other pieces, though, that I do want to make sure we're covering in some detail. Cycle time oftentimes gets very heavily applied only to an application development lifecycle. That is true. It is a very big piece of that. We're going to spend quite a bit of time also today around DOGOps, DevOps, particularly ops. That comes with a bunch of different naming. Traditional, this has been called infrastructure as code. There's a bunch of great tools that do infrastructure as code. Today, we're going to be talking about infrastructure as code, though, in context of something called GitOps, meaning you're checking in that code, you're testing that code, and it lives in Git. We are GitLab, so you can imagine Git is pretty important to us. So that's some context that I want you to have. It's what we measure. If you're looking for what you should measure, we definitely think the best place to look at is cycle time. It's the most encompassing, and it certainly requires both the most work, but it's the measurement that's going to matter the most to your customers. Our challenge that we came to at GitLab, we stumbled over it, so we believe a whole lot in iteration at GitLab. That means we start with a small idea, and we keep iterating as fast as humanly possible. I think everyone maybe does that is pretty familiar with that notion. We've done it to the DevOps lifecycle. This is the world that we see today, the challenges and the solutions. Most people in any decent-sized company are running, if they're running just one tool chain, they're probably running between 8 and 10 different tools. If you're running in a large organization where you may have a huge number of other tools, this is pretty common, if not significantly more complex. There's nothing in and of itself wrong with any one of these tools. They're all very good tools. The challenge is that you're going to find inside of your organization that you're going to have someone that is explicitly the Jenkins fan, and they do all the Jenkins work. There's going to be there's a gentleman on the front that just laughed. He's the Jenkins person. Or he knows a Jenkins person. It could be one of the two. Anyhow, you could live in Terraform, you can live in Circle, you could live in GitHub. You can live in a lot of different tools. The challenge becomes you're not speaking the same language, you're not in the same UI, you're not seeing the same thing that the rest of the group and the company would see. So when we look at where we see this going, GitLab covers a pretty wide variety, but today we're talking not just do source code. We are GitLab, so we love source code. It is a place we have a lot of pride in. We also are, according to Fortune now, the best CI provider for the last 4 years running, both in terms of one you can run in your own VPC in Amazon or managed by GitLab if you wanted alternatively. A couple of pieces in this that I want to make sure we hit is where continuous integration, continuous deployment, and development sit. And so, went one long. These, when you think about what GitLab covers, we're going to cover as a tool, in a single tool, everything from your management plan side. This is going to be your project management, your portfolio management, all the way down to really we ship with monitoring, meaning we ship with like Prometheus. Can you use your own other tools? Absolutely, you can use them together with GitLab. But we see particularly in the middle of this, really from the create to the monitor stage being extremely important for everyone to be on the same page, for the teams to be using a similar tool, and not because it's a tool, but because it facilitates a similar language. You'll see a lot of those, some screenshots as Dave goes through those. But this is the area that we're playing. Now, a couple things that aren't necessarily fully obvious here, so I just want you to have some context to us. There's a bunch of different ways you can engage with GitLab. You can download and run GitLab in your VPC. You can download and run GitLab on top of EKS. Those are two ways to run it. We package the whole thing together. So it's a single omnibus package or Helm chart. You deploy it and you can run it. You can deploy it directly off of the marketplace. Those are all options for you to engage. What you should also know is we've invested a whole lot to make sure that you can deploy it into Lambda, EKS, ECS, Elastic Beanstalk, EC2, you name it. That environment has been both delivered and executed. So last couple things, other places. So Wag has been kind enough. We really want to work with Wag, and I think you guys are going to get a great context of the breadth of what you can do with GitLab, and that's why we want to work with Wag. Notably, we have a number of other customers here that are speaking, so check out Goldman Sachs. They've been with us for a while. Huge transformation for them, and they were a great software shop, as you can imagine already. Their velocity, again, coming back to that cycle time, went from months down to many, many times a day. And for a company that's shipping product like Goldman, it matters immensely. The last piece before we go in here is we talk a lot about speed forward. You're going to see some on speed rollback. So the other question is, code's great, but if you can't get that code, roll back that code if you make a mistake, or push out something new if you have a vulnerability, you're going to miss it. And so this is also part of what you're going to see that Dave covers. So with that said, I think I've covered the majority of the context. You're going to get to play with a bunch, see a bunch of it with Dave, and then we'll be open to questions sort of at the end.
Sounds great.
But the world's yours.
Awesome, thanks. All right, so hey, I'm Dave Bullock. I'm a VP of Technology, Engineering, and Operations at Wag. For those of you who aren't familiar with Wag, we are an on-demand dog walking, sitting, and boarding platform. We're in 43 states, over 110 cities. We provide millions of walks per year, and like most importantly, we create a ton of joy for dogs and their pet parents. We are super pun-heavy and Slackmoji-heavy environment, so this talk will be kind of littered with them, and hopefully they're not too bad. So I'm going to kind of walk through where we were about a year and a half ago when I started at Wag, closer to 2 years now, and kind of walk through like the transition that we made for both our infrastructure as well as our kind of application CI/CD pipelines. So here's kind of a rough diagram of where we were. You can see we had a pretty flat environment. It was literally just like the public VPC default. No. There was this one crazy security group. Things weren't perfect, and there was a lot of room for improvement. So there were some other problems like in the pipeline as well. So first of all, the problem with our application pipeline. To deploy our application, so our core API, it was this really kind of crazy process that all hinged on a single person. That it was like the only person who could provide a release. That ended up becoming 2 people, but it was just a mess. You had to log into different systems, jump around to different places, click buttons. It took a really long time to deploy the changes. It also took a really long time to roll back those changes. So you can imagine if there's a problem trying to roll back, it could be 20, 30 minutes before you're able to do that, which is, as I'm sure you're all aware, is bad. You want to limit the kind of blast radius when there's an issue. We had all these divergent environments. We had our production environment that was completely different than our staging environment, that was completely different than our local development environment, which I'm sure you guys all, the old adage, it worked on my machine, that we heard that all the time, and so that was also not great for us. And then we were using Travis CI, which it's a fine product, although it got bought and they've kind of, anyway. It limited us in kind of 2 different ways. So I think we have maybe 10 or 20 instances through Travis CI, and basically during the middle of the day when engineers would be trying to push code, they would get backed up. It took probably 30, 40 minutes, maybe an hour for like all of our test suites to run. And I think there were 6 suites that would run in parallel. And so you can imagine 4 or 5 engineers pushing their their code, you start having a backup. And there's nothing worse than having an engineer that's just sitting around not being able to work because the pipelines are still running. And then the second bad part about it was that at night, it was just sitting there doing nothing. Maybe we have one engineer working late, but those instances were totally wasteful and were just burning money. And then, as I mentioned, there was a single point of contact and failure for releases, which we really want to empower the whole org. So we came up with a plan, and the plan had a couple of phases that we ran in parallel. So the first piece is automate all the things. So there's our first bad pun. The idea was to containerize the application. I mentioned the infrastructure was pretty flat. It also didn't scale. So not only was our CI pipeline inefficient at night, our actual infrastructure was inefficient because most people don't want their dogs walked at night. So, and we're just in the US, so you can imagine a kind of a Gaussian curve of use of our systems. Those systems were just sitting there doing nothing. So we also wanted to create a safer path to deploy, so enabling canary deploys and a blue-green deployment for really fast rollbacks. And we wanted to democratize the deployment so that everyone could actually deploy the code that they write. Okay, so first step to containerize the application, we built out a pipeline in GitLab using Ansible and Packer that we used to kind of build this base image, a Docker image, and AMIs for other uses, but that would run every single night. We'd get the latest versions of all the different software, so we'd have the security patches, trigger a build anytime there was like a hot security patch that we need to get out, and really push that base image into ECR so it'd be available not only for our production image, but for our local devs to all have the exact same flavors of OS, of web server, of all the things that they needed. We built out a stage in GitLab that would pull that image, push it from our dev environment, push the code into that image, push it back to up to ECR and tag. And we purposely built those images to not have any kind of secrets or config in the image, right? We didn't want to have any passwords, any keys. That way we could use the exact same image in both local dev environments, in tests, staging, and in production. Next piece was to build out an ECS cluster. We were running on static EC2 instances. So we set up ECS cluster. We use SSM and Chamber to pull in secrets and config. Really great usage pattern. I recommend it. Scaled based on CPU. That's where we really kind of saw our load. So that was going to basically save us a bunch of money and increase the scalability of our application. Another key part about it was blue, green, and canary deploys. So the way we do it is we spin up a whole other ECS cluster. So say our blue cluster is hot. We scale up the green cluster, pull in that release image, scale out the cluster so that it matches the production one, so that they have the same the same capability. We start sending 1% of the traffic to that cluster. We monitor like logs, errors, load, everything very closely for a few minutes, and everything looks good. We cut over to that new cluster. Again, we keep monitoring. We look at those logs. We look at the errors. We look at any kind of load spikes. Everything's good. Scale it down. Or if something goes wrong, we can roll it back. And so we implemented this using Amazon Route 53 and a layer of HA proxy. Actually, there's a talk of me on the internet talking about this, but basically we didn't trust. Anyway, this is all pointless now because you can now do this with a new ALB functionality they released like 2 weeks ago. But to do the quick cutover and the rollback, we use HA proxy. And so we wanted to democratize deployments. We wanted to empower every single team to own end-to-end the code. We wanted the developers to be able to work locally, make changes, push them up, go through QA, and then push the actual button to roll it into production, and then monitor afterwards so that they take ownership. They're not throwing it over the fence to an ops team, that they really are responsible end-to-end for their code, which is just really important. So with a simple web interface using GitLab, we could do database migrations, the canary deploy, the cutover, and rollback if necessary. And it really got the whole team to own the code that they were writing, which is so important, right? Everyone should feel that the work that they do as a developer, they own that all the way through into production. And
what did you see for history? What did you see for your team as you made through this transition? So what did the app team think once you got going?
Yeah, I mean, so ops doesn't really want to be responsible for someone else's code. They want to be like part of the team, right? They want to be like a member of the whole flow. And so the ops team felt great because they're not having to do the deployments and own it. And B, the engineers felt like that they were empowered so that they could actually do their own deployment. So it was great on both sides. Yeah, win-win. And so by empowering the teams to release their own code, you increase release velocity. They're releasing a couple times a day, whenever they want, really. Even Friday deploys, we do Friday deploys, no big deal. Reduce the risk. Many frequent small changes are much safer than large major changes to any system. Second problem, and this is where I kind of touched on in the beginning, is that our infrastructure was a little bit of a mess. We had a catawask that was infrastructure as clicking around the AWS Management Console. Not ideal. I'm sure we've all been there. We've done this,
Clearly,
right?
no one in the room has done this. No one in the room
We've all
has
done this.
Did you trademark this? Have you trademarked
Not
this?
yet.
You really
I don't want to take ownership of this one. But
okay.
yeah, so we've all done this. It's fine for like prototyping, but our entire system was running on just like something that was completely not repeatable. There was no auto scaling, so everything was fully static. Totally flat VPC, no subnets, no NACLs. There was no staging environment to test like infrastructure changes, and there was this I call it one security group to rule them all. It was literally applied to like everything, like database servers, web servers, load balancer, everything. Once I went in, I had to make a change. I was going to add like an IP that could access the database. I accidentally changed a rule instead of adding a new one, and apparently I changed the quad 0443 rule. We also didn't have great monitoring at the time. Customer service let me know about half an hour later people can't access the app. So definitely was not ideal. There's a lot of room for improvement. So we came up with a plan, phase 1B, re-architect the infrastructure. So this was going to be some heavy lifting, but we wanted to define everything as code, make sure everything auto-scaled, everything was in a single AZ. We wanted to make it all multiple AZ, tiered VPC subnets, minimally permissive NACLs and security groups, and enable application deployments via GitLab. Sorry, 1 second here. So, redefining everything as code. We wanted code, not clicks, right? We don't want that ayahuasca thing or whatever. Terraform, all the things. We're big fans of Terraform, so we basically, redefined the entire system in Terraform. At the time, there was only one dev who was working on this, which was me. And so I just did a single mono repo for everything, modules, environments, everything in one single repo, which is also not ideal. And as you can see, I had to refactor a few of those things. And then in each of our different tiers, we had a separate AWS S3 bucket for state and DynamoDB for locking, which also had its own problems and is not how Terraform recommends that you manage state. And nothing was hard-coded, mostly. Some stuff was. And this required some refactoring, which we'll get to later. So yeah, everything auto-scale, multiple AZ. We built things in Terraform so that we could say, okay, like in our local environment, we only want one AZ. In our production environment, we want 2 AZs or more, whatever we decided on. It's just a variable that we could change. We built everything so that there was no single point of failure, so fully HA all the way through. Auto scale with variable instance sizes, so you could basically say, in my local dev environment, I want T3 micros, but in production, these are C5 X larges, whatever. And then we built a sandbox and a stage with the exact same architecture as production, but on a much smaller scale, so it doesn't burn a bunch of money. Tiered VPCs, so subnets for every tier. So our APIs, our workers, different services had their own tiers. Database had its own tiers. Cache had its own tiers. The ALB, NAT gateway are the only things that were public subnets. Everything was locked down. Lockdown between tiers. So the database, subnet can only be accessed on port 3306 by the applications subnet. And then security groups to match because you want the stateful rules. And then we turn on flow logs. So we definitely improved the whole system, and we went through AWS well-architected review and passed it after we changed this. We wanted to enable those deployments. So we wanted to build out the Terraform pipeline to actually, the GitLab and Terraform pipeline to run this. We built out GitLab runners using STS assume roles, so that we basically had we have an account where the GitLab lives, where the engineers can do deployments that actually affect production levels. So there's no need to log into any systems, no moving code around, no running commands. You're just clicking all through Terraform and GitLab.
Quick note on this, just context-wise. GitLab has 2 primary pieces: GitLab, which you know for the Git space, and all of that code. The GitLab runners are where you do your CI builds, because those are going to need different scale, and it's just a Go binary that runs anywhere. So just context on that, so you know what those are.
Yeah, and GitLab has this great functionality where they do auto-scaling runners. So basically, you can, before we had those static runners in Travis CI that were 20 on at a time, With auto-scaling runners in GitLab, you basically say, okay, I want up to 500 at a time, and you can set windows of like when they're active. So it's really, really efficient, got rid of a ton of our bottlenecks in the pipeline. So a few months later, success. Mostly not everything was sunshine and rainbows, but piece by piece, we moved all of our live production platform, like the whole changing the plane out, while it's in flight thing. We empowered the teams to do their own deployments, which is awesome. The systems were finally scalable. They were locked down. Like I said, we passed that AWS Architecture review, saved a ton of money, like significant amount of money, like a lot, like 60% less we're spending today than we were about a year and a half ago per month. Increase that release velocity, which is gold, and reduce that risk of deployment. So yeah, not everything was sunshine and rainbows. There were some issues along the way. So here's what the architecture looks like now. And this is obviously simplified, but you can see that layer of HA proxy on the front there. The main reason for that is that you can do with a weighted CNAME, you can do a canary deploy with just Route 53. The problem is we don't really trust like Verizon or Comcast to respect the TTL on that DNS record, and so we use HA proxy to literally just check Route 53 every minute or 20 seconds or something to see if that CNAME has changed, and then start sending traffic over to the other cluster. So like I mentioned before, this was about a year and a half ago, and I always talked about in the other talk I said, okay, at some point Jeff Barr is going to post like, oh, we've updated the ALB, and now you can do like canary, and so now you can do canary and blue-green deployments on the ALB directly. So this is what our pipeline looks like. I don't know if you can see that, but basically in the first stage there, you have we build our image. We have some like basic test suites, the unit tests that run against that image. And this has actually evolved a little bit since this slide, but then you have functional tests. Then right here, you see this little test QA. That's what GitLab calls a review app. And basically what it does is it allows a human to basically click a button and spin up a whole instance of your application that you can then point to like your mobile app to, or your web browser, and actually test the application. And then when you merge, it gets torn down, or you can tear it down manually. And then we have a bunch of analyze tests that are like these things you get for free with GitLab Ultimate that basically scans your code for static analysis, dynamic analysis, what else?
License checking.
License check, container scan, and dependency scan. So all really useful. We drop that in the pipeline. And then this pipeline continues, and it kicks off that other project, the Terraform deploy, which then basically spins up, notifies the Slack. So here's what it looks like. It notifies the team on Slack. It pulls the image from ECR from our QA environment, puts it into a production environment, spins up that cold cluster, and then notifies us that it's ready to go. And then that's when the manual part comes in, where you basically click a button and say, okay, let's get the cluster ready. Let's do these DB migrations. Let's do the worker deploy. And then we do the canary deploy. And each of these stages, you can see, has a rollback step. So if anything goes wrong at any of these places, another click of the button, we roll back to our previous state.
Trust your pipeline.
Yes, it's all in the pipeline. And then it's all tied into Slack. So all through the pipeline, it's basically kicking off messages to various channels saying, okay, hey, we did this diff check. Here's the image is ready, the cutover has happened, the rollback has happened, all that stuff. So automated that whole thing. Wasn't perfect. Let's talk about what went wrong. Emojis. Party trying not to cry. So change is hard. We changed a lot throughout this process, and whenever you change a lot of things, like things are bound to break. Systems in general are complicated, especially when you inherit like a big legacy system. And then even moving stuff to new systems, there's little idiosyncrasies and weird problems. Things, when you're making a large amount of changes, things are going to fall down and break, and that happens. Nobody is perfect, and people, especially me, make mistakes. But onward. So that's kind of phase one. That's the application pipeline. So phase two, after we kind of released this and got people using it, we needed to add into the deployment pipeline. So I didn't quite fully think through all the different use cases people would kind of fall through. I thought, oh yeah, happy path. Every engineer is like, we all make this mistake. We just think the happy path and build that, and then people start testing it and using it. Am I losing battery? Sure. Oh. Sorry, technical. Okay. Ooh, that's loud. Okay, so yeah, so we think of the happy path, and then people start actually using the product. In this case, the product here was the pipeline that I built, and they find edge cases and corner cases, and things fall down. We also wanted to do the full software development lifecycle for our infrastructure. So the app was great, but why not? We're defining our infrastructure as code. Let's get the whole thing in a pipeline. I talked about that monorepo. It wasn't optimal or ideal, so we need to split that up. And we wanted to move to that multi-AWS account, AWS, the S3 background, which Terraform recommends as the best way to use when you have multiple AWS accounts that you're managing with Terraform. And plus, we wanted CICD for those Terraform repos, and we need to scale out the team because it doesn't make sense to just have one person own all this stuff. So just a little recap of where we were, and then here's where we ended up. Also very simplified, but gives you a general idea. You can see everything is tiered out in different subnets, all locked down, all multi-AZ, so in a much better place than we were before. So guardrails. The deployment pipeline was possum perfect magic until it wasn't. Like I said, if you didn't do things in the right order, like if you kind of waited too long for something to cut over, and then you cut it over, the cold cluster would auto scale down and wouldn't be able to handle the load. There were just things that didn't go quite perfectly. So basically, we added guardrails and continue to prevent bad things from happening. Uptime is good, downtime is bad. So yeah, add those guardrails into your pipeline so that you can protect you and your engineers from yourselves. We wanted to follow the full SDLC for Terraform. So we have our infrastructure as code. We want the normal life cycle, just like we use for our applications, for our Terraform repos. So basically, the kind of the flow that we did is you cut a branch from master. You test. Each of our DevOps engineers had their own AWS sandbox, which they could have an exact copy of what we had in production, but at a small scale, so it wasn't burning money. Push your branch when you're happy. Linting in the test run. You get a code review. Everything looks good. Merge your changes in, and then automatically stage and test those changes. Now we have these parity staging and production environments. Might as well just run those changes automatically and test against them. Then this is where the automatic stuff stopped happening. We would run a Terraform plan against production, save the state output or save the plan output. That kicks off a message in Slack. We review that, and then if everything looks good, you apply the plan. Shred the monorepo. Didn't make sense to have this one massive repo, and I know people will argue with me about this, and it's fine. It works either way, but definitely adds complexity to have 40 different Terraform repos for all our modules and for our environments. But for us, it just made sense. We wanted to be able to lock modules to a certain tag. We didn't want to change on one module to break some other environment. So because we had our prod environment, we had data, we had ops, we had QA environments. And so each of those environments also had a staging version of those environments. And so luckily we built out the production repo with kind of the same grunt work style of a specific path and then environment. So it wasn't too hard to split them up. This is I talked about a little bit. Terraform HashiCorp has a great article about how to do this, why it works really well. But basically, we created a single AWS account that only held basically three things. So a single AWS S3 bucket for state for all of our environments, DynamoDB for locking, so single DynamoDB for locking, and then IAM users and roles for STS assuming in our pipeline, but also for our various engineers to have access across those different environments. We use those roles to kind of lock down access within that S3 bucket so that the local engineers weren't actually accidentally making changes to production. You have to go through the pipeline. We use workspaces and role assumption to share that same Terraform code for a production environment to your sandbox and to a staging environment. It made testing, staging, and deploying much easier to scale. And yeah, there's a great article about that. If you just Google Terraform AWS S3, they talk all about it. And we wanted to use CICD for our Terraform as well. So we're following the full software development lifecycle for building this stuff. Let's automate all the things. So we built out pipelines for running those tests, for staging, for planning, and eventually for applying those changes in GitLab. So you basically push the code up, you get pinged in Slack, and Terraform plan, click to apply. So let's see here. Oh yeah, and building out a team. So it didn't make sense for me to kind of just do all this stuff myself. We needed to find some great engineers. Finding great engineers is hard. Finding good engineers who Terraform is also hard. So I think it's super important to hire people who are passionate, hire people who care about the mission, about what we're doing. Obviously, they have to love dogs. In our case, I mean, maybe your case too. It's a good way to tell people are good or not. Hire people that are excited and want to learn and grow, and hire people who like bad puns and dog puns, and bad dog puns. So a few months later, success. We split out the monorepo, created a full CI/CD pipeline for our infrastructure. We built out an amazing DevOps team. We onboarded the team, and they didn't all rage quit. And we came up with so many bad tongues, so many bad dog puns, and not everything was sunshine and rainbows again. But here's our pipeline. So again, kind of hard to see, but first step is like a lint check of the Terraform syntax. Then we check to see if there's any changes in either NACLs or security groups, and ping our security team. We pull our production images of both master and develop from ECR, and then we push that into our staging environment, and then we automatically plan and apply all those changes from the through the pipeline. Fully automatic changes applied. If anything breaks along the way, this next little round of tests will fail, and then we'll inspect what went wrong. And then once those tests pass, then we run the plan against all of the different pieces of the environment. If there's any changes to those plans, we basically ping out in Slack, and then we go through and review those. If everything looks good, we click those manual apply buttons, and then it applies the Terraform automatically into the various environments. So here's what it looks like in Slack. You can see that you get a notification, based on what's changing. A handy little link to go right to that plan output in GitLab and see all the changes before they happen. And then if everything goes well, you can click to apply. That doesn't actually apply the changes. It just takes you back to the pipeline. We felt it was a little dangerous to have a button in Slack to just apply changes. But you click once the changes have been applied, you get another notification saying, okay, these have been applied, and you can view the output, and hopefully our other channels don't start blowing up with error messages. So what went wrong? Same exact stuff. Change is hard. This was a much bigger change. Kind of moving to from a single person managing Terraform on their local system, running Terraform commands manually on the command line, to using CI and CD for actually running those changes and applying them in production. It was a big change. There's a lot of different moving pieces. Instead of just using my AWS credentials, we're basically having these GitLab runners assume roles in the pipelines and making changes. Things broke. As we were doing this, we made mistakes. Things fell down as we were applying things. We moved around a lot of stuff, but at the end of the day, it ended up really good. So, and of course, nobody's perfect. We all make mistakes, but now that it's software, now that we're not doing things manually, it's much easier to kind of recover from these mistakes. When you follow the software development life cycle, you have the chance to catch mistakes early in the staging, catch mistakes in code review, and if things break in production, you can roll back and recover. So you're in such a better place when you're managing all your infrastructure as code. And then of course, we all we make mistakes and recover. So yeah, onward. Thank you.